Hi, this session is on measurement revision. So we'll be revising skills that we have learnt in perimeter or length and perimeter, area and volume. So with each question, please make sure you write them down and try and draw the diagrams as well, and also have a go first. Then you can correct your work by watching the lesson, or if you get stuck, you can watch the lesson to see how the questions are done. You can use a red pen to correct your work as well, to show that you have tried it first. So the first thing we'll look at is reading scales. And question 1 says, at what length are the following points? So you've got 4 points, A, B, C, and D, and they want you to write down the value of each of those points. Okay, before we even try to work out or guess what these values are, A, B, C, and D, understand what the scale is telling you, what it's showing you. So we can see it's a ruler, and our units are centimeters. So every unit we see here, like 1, 2, 3, it's saying 1 centimeter, 2 centimeters, 3, 4, and so on. So there are larger units on this ruler, but there are also smaller units breaking up our centimeters. So if I focus on 1 centimeter, I can see there are 10 smaller units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they are our millimeters. We know 10 millimeters makes up that 1 centimeter. Now we need to work out the value of millimeters in terms of centimeters. Because our units are in centimeters, our final answers should be written as centimeters, not millimeters. So to work out how much centimeters we have, so if I have 1 millimeter here, 1 millimeter would be how many centimeters? Now we have also learned how to convert, and we can use a conversion chart. But another way so you can work it out this way, but I wanted to show you another way. And that is, we can work out what each unit is worth in terms of centimeters by first get your whole centimeter. We've got 1 centimeter, okay? So I'm going to write it as a fraction. 1 centimeter is divided into 10 smaller parts. So divided by 10, okay? That's saying every millimeter is actually 1/10 centimeters, 1/10 of a centimeter. So that would equal, in decimal, 1 divided by 10 is 0.1 centimeters. So if you change 1 millimeter to centimeters, you would have had 0.1 using your conversion chart as well. But this is another way of doing it, and it's useful to know when we have different types of scales, as we'll see in our next question. So just to make sure you understand, it's saying that 1 millimeter, there's 1 millimeter. Instead of writing it as 1 millimeter, I'm going to write it as 1/10 centimeters, or I can just say 0.1 centimeters. Okay, we'll use decimals, but it's important to understand we can write it as fractions as well. So the second one there, we've got 1 millimeter. So instead of 2 millimeters, I'm going to have 2 parts out of 10, which is the same as 0.2, but it's centimeters. Okay, so 0.2, and I keep going. 3 parts out of 10, or 0.3, 0.4. Now I can see this line here is longer in the middle, which is telling me it's halfway. So we know half of 1 would be 0.5. Okay, but as a fraction, that would have been 5 parts out of 10. If I simplify that, divide them both by 5, I would have a half as a fraction. But if you're not confident with fraction skills yet, that's fine. We haven't learnt fractions yet. Just write it as decimal. So all the way, we've got 0.1, 0.2, 0.3, 0.4, 0.5, all the way. And when we get to 1 centimeter, remember 1 centimeter would be 10 parts out of 10. Okay, 10 divided by 10, I get my 1. That's why we get a whole number 1. And the decimal stops. Okay, now that I know what each unit is worth, even the smaller units in terms of centimeters, I can now work out what A, B, C, and D are in terms of centimeters. I'm also going to put, now that I know that it's halfway, so I've got 0.5. Here I've passed 1 whole unit, or 1 centimeter, so I've got 1.5, 2 wholes, so 2.5, 3, 3.5, 4, 4.5, and I can stop there. Alright, so now the value of A, I can see A would be equal to, it's right at the beginning So the length would be 0 centimeters. Okay, so I'm at 0. B, we can see it's pointing to 0 up to 1.5. So B would be equal to 1.5 centimeters. C, now C is actually halfway. It's in between this millimeter and that millimeter. So we're going to work out halfway of a millimeter. So to do that, first we're at 2 here. So I've got 2 centimeters. So I've got 2.1, 2.2, and then 2.3. So C is in between 2.2, I'll just write it up here, and 2.3. So C is halfway between 2.2 and 2.3. And I'll show you a trick to work out halfway between decimals, in this case 2.2 and 2.3. A trick is, write them as, add a 0 at the end. So imagine I've got 2.20 and I've got 2.30. It might help doing it this way. What's halfway between 20 and 30? I know halfway between 20 and 30 is 25. So I would have 2.25 centimeters. So that's halfway in between those 2 millimeters. And the last one, D, I've got 3 as my whole number, so 3.1 and 3.2. So D would be equal to 3.2, and don't forget to write your units centimeters. Okay, question 2 says read the values shown on the following scale. So once again, we're doing the exact same thing. So have a go first, try and work out what the smaller units are worth, and then you can work out what these 3 values are. So if I read my scale, I can see it's going up by multiples of 50. So 50 mils, then 100, then 150, 200. So the space between the larger units is 50 mils. Okay, so from here to here, it'll be 50 mils, and it's the same all the way through. Now, this 50 mils is also being broken up into smaller units. And I've got to work out how much is each of these units worth. What's their value in terms of mils? So let's work out how many smaller units in between 50 and 100. Let's see, we've got 1, 2, 3, 4, 5. There are 5 smaller units in between 50 and 100. And remember, it's a total of 50 mils. So if I've got 50 mils as my large unit, so in between 50 and 100 is 50 mils, and I divide that by 5 smaller units, that will tell me, so you can write it like this as well, if that makes more sense, divided by, that fraction line means division as well. I would have 50 divided by 5 leaves me with 10 mils. So that's saying every small little space is worth 10 mils. And let's see if it adds to 50. So 10, 20, 30, 40, 50. We got it. Perfect. So now that we know that, we can easily work out the value of each of these points. So for the first one, I'm at 50 mils, so I'm going up by tens. So 50, 60, 70. So the first one was 70 mils. Now this one here, I'm at 100 mils now, so go up by 10. 100 plus 10 is 110. So the second one was 110 mils. The third one is all the way up here, so it's going, so the next large unit I can see is 150 mils. So I've got 150 and count by tens. 150, 160, 170, 180, 190. So that will be 190 mils. And that's our answers. Our next section is looking at converting units of length. So maybe a good start would be to draw your length conversion chart. And question 3 asks us, complete each of the following metric conversions. So for A, you're turning kilometers into meters, B, meters into millimeters, and C, centimeters into kilometers. So please have a go first. Now you don't have to use a conversion chart, you can actually do this mentally, but I still want you to be able to draw it just in case you need it and it's a useful tool. Okay, so once again, you should be able to draw this on your own. We start with kilometers and our units get smaller. Kilometers, meters, centimeters, millimeters. And when we go from a bigger unit to a smaller unit, our number gets larger. So we times. A smaller unit to a bigger unit, we divide. So if I've got 4 kilometers and I want to turn that into meters, if I'm at kilometers, and there's meters, I've got to times by 1,000. To get from here to there, I times by 1,000. So for A, I've got 4 times 1,000. Now make sure you can do this without a calculator. So all these questions you should be able to do without a calculator unless the question asks you to use a calculator. So to do this mentally, 4 times 1 is just 4. Add the 3 zeros, 1, 2, 3. So my answer would be 4,000 meters. And it makes sense, starting with a bigger unit. You start with bigger, you get bigger. We started with kilometers, which is bigger than meters, and our number got bigger. Okay, so for B, 560 meters to millimeters. So once again, bigger unit to a smaller unit. If I start with bigger, my number should be getting bigger. This is just a way to remember. So meters is over here, and I'm going to millimeters. So now I'm going to have 2 steps, times by 100 and then times by 10. So that means 3 zeros altogether. So if I get my 560, I'm going to say, okay, times by 100, so I'm at meters, so times by 100 first. I'm not at millimeters yet, one more jump, times by 10. So if you write that as one number, 1,000 times 10 is, put the zeros together, we just have 1,000. That's also correct. So what is 560 times 1,000? All we're going to do is add the 3 zeros onto 560. So 560, add 3 zeros, 1, 2, 3. Put a comma in, 1, 2, 3, comma. I have 560,000 millimeters. And for our last one, we are going from centimeters to kilometers. Now centimeters is a smaller unit. So because I'm starting with smaller, my number, 480, should become smaller. If you start with smaller, you get smaller. So there's centimeters, and I want to go to kilometers. So I have to divide by 100, follow the arrows, and then divide by 1,000. So I'll do C over here, the working out. So 480, I have to divide by, so I'm at centimeters, divide by 100, and then divide by 1,000. So I can put that into one number. I'm dividing by 1 and 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. That is 100,000. Now once again, you should be able to do this without a calculator. When dividing by powers of 10, so 1,000, 100 or 10, 1 and zeros, all you're going to do is move your decimal point. Okay? So we're multiplying and dividing, we're just moving the decimal. So I've got 1, 2, 3, 4, 5 zeros. Division, our number's getting smaller, so we're going to the left. I like to add in some zeros first. You don't have to, you can add them in later. And let's move it 5 times. So 1, 2, 3, 4, 5. My new decimal point is over there. So my number is 0.0048. 0048. We don't have to write that 0 at the end. We don't need it there. So you should have had 0.0048 kilometers. Okay, question 4 asks us to arrange the following in ascending order. So remember what that keyword means, ascending. So have a go first. So ascending means from smallest to largest. Like A for a rise, when you rise up, you start from the bottom and go to the top, so smallest to largest. Okay, so to arrange these from smallest to largest, we have to make sure they are all in the same units. Now it's up to you what units you choose to change them all into. You might change them all into millimeters, or you can change them all into meters or kilometers. It's up to you. Remember, if you start with a bigger unit, your number gets bigger. So if you want to avoid decimals, you can change the kilometers and meters into millimeters. So let's do that. So I'm going to change 50 kilometers is equal to how many millimeters? And 500 meters is equal to how many millimeters? I can leave this one here. It's already in millimeters. So 50,000 millimeters is done for me. Just change those two and then arrange them. So kilometers into millimeters. Once again, you can use your length conversion chart, or you can do it mentally as well. So kilometers to millimeters. Here's kilometers. There's millimeters. I'm going all the way to the end. So I've got a times by 1,000, times by 100, and times by 10. Altogether, that's 6 zeros, so 1,000,000. So for this one, I'll just do the working out down here. I've got 50 times 1 million. So 6 zeros. So 1, 2, 3, 4, 5, 6. So just add on 6 zeros to 50. And 1, 2, 3, 4, 5, 6. There I am. Let's read this number. So add a comma, 1, 2, 3, comma, 1, 2, 3, comma. So I have 50 million millimeters. And the next one, I'm changing 500 meters to millimeters. So meters is over here. So I times it by 100 and I times it by 10. So altogether I've got 1, 2, 3 zeros. So 500 times 1,000. So write down 500 and add those 3 zeros. So 1, 2, 3. So 500 meters is equal to 500,000 millimeters. Now that they are all in millimeters, let's arrange them from smallest to largest. So out of these three values, I've got 50,000 millimeters, I've got 50 million millimeters, and 500,000 millimeters. The smallest one would be the millimeters, the 50,000 millimeters. That's my first one, so small to largest. So as my final answer, I'm going to try and write down the units from the question. So 50,000 millimeters was smaller. Next one, well, out of I've got 500,000 millimeters or 50 million millimeters. Well, 500,000 is smaller than 50 million. So 500 meters would be next. So 500 meters. And I can't fit it there, I'll just squeeze it down here. That means 50 kilometers is the largest one. And it's the third one I write. That's a 0. Okay, so ascending order from smallest to largest. Okay, the next section we are working on is perimeter. So please write down this question and have a go. Okay, so there's two parts to this question. They want us to work out any unknown side length. So I can see this length here has no measurement and this one here has no measurement. So I've got to work out these unknown side lengths. That's what that means by this part here. And then work out the perimeter. So adding up all the sides. So when it comes to L shapes, sometimes there's different ways to work it out. But just remember, an L shape was once, we can say it was once a part of a rectangle. So someone's cut out a piece of this rectangle to form an L shape. Okay? That's one way of looking at it. And that can be useful when working out unknown side lengths or even the perimeter. So to work out this, we'll start off with this one here. I can see that the length from here to here, if I was to draw it down here, would go from there to there. Okay? Just do a dotted line. So that's my length that I want to find. I've just drawn it down here. I can see it's a part of this line, which is 6 centimeters, but not the whole 6 centimeters. So if I can just cut off this part here, I would be left with that length. Well, what's the length of this part here? I can see it's 4 centimeters. Okay, that's the same length. So if I go 6 take away 4, that will leave me with 2 centimeters. So that means this length is 2 centimeters. Okay, and from there to there and there to there. And I can see if I put 2 there, the 2 plus that 4 would give me 6 as well. So I can see it's correct. So I figured out this unknown side length. So I've got 2, and now I want to work out this unknown side length here. Okay, and I can see from here to here it's 8 centimeters, and I'll be doing the exact same thing. If I know from there to there is also my length, the same length, the same line. I've just drawn it on the 8 centimeter line. So if I can work out what this part here is and cut it off, subtract it, I'll be left with this length here. So what's the length of this part here? Well, I can see it's 3. Okay, that is 3. So if I go, okay, the whole line, 8, take away this part, which is 3, it leaves me with 5. So that means this length is 5 centimeters from there to there. So now that I have worked out the unknown side lengths, because the question asked me to do that first, I will work out the perimeter. So all I got to do is say P is equal to 2. We can start with 2 plus 5 plus 4 plus 3 plus 6 plus 8. Add them all up and that will give me my answer. We add them up, I got 28 centimeters. So that's our perimeter, the length around the shape. Okay, question 6 asks us to find the perimeter of the following polygon. So a polygon is any shape with straight sides and all joined up, or straight edges. So we can see that. So work out the perimeter of this shape. Now we don't know what the individual lengths are here. There's no value, but we actually don't need to know that in order to work out the perimeter. All I need is that 20 millimeters and that 15. And if you're still confused with these kind of questions, it's good if you can use matchsticks to draw this shape up, to construct this shape. It's actually useful that way, and you can move the matchsticks around. So I'll try and show you this way. This length here, plus that length, plus that length, plus that length, and that one, they all, if I pull them all together, they would make the same length as 20 millimeters. Okay? So if I just say, if I pulled that length there, it goes up to there. If I pulled that one, it goes there. If I pulled that one, just like they were matchsticks, and that one is from there to there, and that one, you can see how just by pulling them, they form that line. So it's the same length. And the same thing happens with the vertical lines here. This one, plus that one, plus that one, plus that one, and that one. If I pulled them across, they would also make 15 millimeters. If I pulled them outwards, guess what? We would have a rectangle. And a rectangle opposite sides are equal. So if I pulled out all of these lines, they would form the same line. That's another way of looking at it. So basically, I've got a rectangle. So 20 plus 20 plus 15 plus 15 is my perimeter. Or we can say 2 times 20, if you want to try another way, plus 2 times 15. So we're left with 40 plus 30, which gives us 70 millimeters. So that is the perimeter of my shape. Okay, question 9 says, up to question 7. So question 7 says, you have been given the perimeter for the following shapes. Find the unknown side lengths. So where the question mark is, they want you to work out what length is that line or side and what length is that side. Okay, so just remember, we are not finding the perimeter. They've told us the perimeter for each of these shapes. Using that information, we can work out an unknown side length. Let's start with A, our triangle. So first of all, what is the perimeter of a triangle? The perimeter of a triangle is adding up the 3 sides. So if I just said, okay, perimeter is adding up 2 plus 4 plus question mark. I don't know what that is. I'll just put the question mark because they've got it there. Now, but I know P is 11. So I'm going to write 11 there instead. So 11 is equal to 2 plus 4 plus the question mark. Now, let's add up. Well, what is 2 plus 4? 2 plus 4 is 6 plus something to give me 11. You can actually write this this way as well. What is 6 plus something to give me 11? It's the same thing. We call this an equation. So it's the same equation. Now, you can solve this using equation skills. If you haven't learnt equations, that's okay. You can just solve it by just using your knowledge of addition. What is 6 plus something to give us 11? Well, I know 6 plus 5 gives me 11, which means that this question mark, this unknown side length, must equal 5 centimeters. So that's the answer, 5 centimeters. 2 plus 4 plus 5 gives me my perimeter. And for B, I'm doing the same thing. I've got a square. Now, they haven't actually told us any number other than the perimeter is equal to 20. That's all they've told us. Well, I know a square, we can see, has equal side lengths. So if I find one side length, it's the same for all of them. So perimeter of a square is divided into 4 parts. Okay, so if I know the whole square is 20 and I've got to divide 20 into 4 parts, I can work it out. So if perimeter is 20, to work out this unknown side lengths, well, I'll just go 20 divided by the 4 parts. What's 20 divided by 4? 20 divided by 4 is 5. That means each length must be 5 meters. Okay, and let's check 5 plus 5 plus 5 plus 5. Yes, gives me 20. So in this case, our question mark was equal to 5. The unknown side length is 5 meters. Okay, the next section we are working on now is area. And question 8 asks us, find the area of the following rectangle. So I can see this rectangle, they're actually showing us the area by breaking it up into all of these squares. So yes, you can count all of these squares individually, but we know a faster way. The area of a rectangle is simply length times width. So the length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now they haven't given us units, so we can just say 12 units. It could be centimeters, meters, we're not sure. And then the width would be 1, 2, 3, 4, 5, 6, 7, 8. So 8 units. And then 12 times 8, so area is equal to 12 times 8. So area would be equal to 96. We can say unit squared or square units. So 96 square units. And that is our area. Okay, question 9 says find the area of the following polygons. So make sure you're able to identify what shapes these are, what are the names of these shapes, and from there use the formula to calculate them. Okay, so for my first shape, I can see it's a parallelogram. Opposite sides are parallel. It looks like a squashed rectangle, but opposite sides are also equal. So the area of a parallelogram is base times height. And we've learned why we get this formula. Make sure we know, remember the base is part of the parallelogram. So base is always part of the shape. So my base would be 6 millimeters, okay? Part of the parallelogram. So 6 times, and height has to be perpendicular. It goes straight up at 90 degrees to the base. So we form that L shape straight to the opposite line, okay? And that length from here to here is being shown over here. I can see 90 degrees perpendicular. So the height is 8 millimeters. So 6 times 8 will be 48 millimeters. Area, we use squared. So that's my answer for that one. The triangle, whenever you're given triangles, you can actually rotate them if it helps, or any shape, to get a better view or understanding of what they are, or what they're showing you. But this one was just like that. So if I have a look here, I'm given a lot of numbers. I don't need them all. I know the area of a triangle. Write the formula first as part of your working out. Is base times height and divided by 2. So I've got to identify which one's my base, which one's my height, and then divide them by 2. So I only need 2 of these numbers. So I know once again the base and height are perpendicular, and the base must be part of my triangle. So the base is either 7, 8, or 5. Now, it can't be 8 because there's no line, no height perpendicular to it. It can't be 5 either. I don't see a line perpendicular. But with 7, I can see 4 is perpendicular, okay, to the base. So if I rotate it this way, we can also see that L or T shape. 7 is part of my triangle. It's my base. There's my perpendicular height, which is 4. So area will be equal to 7 times the height, which is 4. Divide that by 2. Area is equal to, I'll just work out, so no calculators, I'll work out the top one first. So 7 times 4 is 28 divided by 2. So what is half of 28? Half of 28 would be 14. And my units are centimeters squared. Okay, question 10. You have been given the area of the following rectangle. Find the unknown side length. So just like the ones in perimeter, we're doing a similar thing. So have a go first. Okay, because I'm working with area and I have a rectangle, I will write the formula. Area of a rectangle is equal to length times width. Okay? Now, I am given, I can say this is a width, the shorter side, but I'm not given the length. So the question mark is saying, what is the length of my rectangle? Now, area A is 50. So if I replace A with 50 equals, I don't know what L is. I'm trying to find L, my length, times, I can see my width is 5. So I've just filled in the information given to me. Now, all this is saying is, if it helps, you can just rewrite it like this. L times 5 is equal to 50. If that makes more sense, it's the exact same thing. So what is something times 5 to give me 50? So we can work it out this way. Or you can solve it as an equation if you've learned equations. But what is something times 5 to give me 50? I know that 10 times 5 gives me 50, which means L, or the question mark, will have to equal 10. And let's check 10 times 5, yep, is 50. So 10, don't forget to write centimeters as well. So let's move on to volume. So question 11 says, what is the volume of the following shape? So when it comes to measuring volume, we have learnt volume is measuring cubic units. So counting how many cubes that make up my shape, or that can fit inside a 3D shape. So here I can simply count. I've got 1, 2, 3, 4, 5, 6. So this would be 6 cubic units. So 6 cubes make up my volume. Okay, and now question 12 asks us to find the volume for the following prisms. So we have learned how to work out volume of prisms and how the formula actually works. So have a go first. Okay, so the volume of any prism, we have learned volume is equal to area of the cross section times the height. Okay, which is the length from the cross sections or the bases. So the other formula we use for rectangular prisms is length times width times height. Okay, which summarizes all of that. So if I have a look here, I can see I've got 9 for this length here and 7. So they're focusing on this base here. Okay, and what is the distance from this base to that base? That would be my height. So the distance from that base to that base I can see is 15. There's a length or height of 15. So volume will be equal to length times width. So I can say 9 times 7, that's my rectangle, the area of the rectangle, times it by 15, the height, and that will be my answer. So 9 times 7 is 63 times 15. You can use an algorithm to work this out. And we should get 945 centimeters, and we're measuring in volume, so 3D, so centimeters cubed. Okay, for this rectangular prism, once again, we're given 3 measurements. So I've got 2 for this length here, 9 for this length there. So if I go 2 times 9 or 9 times 2, I am finding the area of that front rectangle. Okay, there's also the exact same rectangle at the back, and the distance between them, the height or length, is 5 centimeters. So my formula once again for volume is equal to, for rectangular prism, we got length times width times height. So volume is equal to, we can say 9 times 2, which is the area of that rectangle, times it by 5, and it will give me the volume. So 9 times 2 is 18, and 18 times 5, can quickly calculate it like this as well. So 5 times 8 is 40, add the 4, 5 times 1 is 5, plus 4 is 54. So 540 centimeters cubed. So 5 times 8 is 40, the 0 down, add the 4, 5 times 1 is 5, plus 4 is 9. So we get 90 centimeters cubed. That's the volume. Now this prism, we call this one a cube because we can see all the sides they're showing us are equal in length. So this cube is made up of squares all the way around. So that would be 10 kilometers. That would also be 10 as well. Okay, so once again, the volume of a prism, in this case a cube, would be length. So the volume of a rectangular prism is the same as a cube, but because all the lengths are equal, we can just say L times L times L, because all the lengths are the same. Okay, so we've got 10 times 10 times 10. So the first 10 times 10 gives me the area of that front square, and that length here is the height or distance between the front square and the back square. So I've got 100 times 10, the area is 100, times 10 to get the volume. So just add the zeros together, 1, 2, 3, so kilometers squared. So I have 1,000 kilometers squared. Cubed. We are doing volume. So our final answer, make sure you got a cube there. Okay, so the final section is looking at extended questions, so applications, applying our knowledge into the real world. Okay, so try this question first. It says, Diane buys a length of rope and cuts it into 3 smaller sections, each of length 7,200 centimeters. How many meters long was the original piece of rope? So let's make sure whenever you're working with real life problems, if it helps to draw a diagram to understand what the question is asking. So it's saying Diane bought a length of rope, so imagine that's our rope, and she cut it into 3 smaller sections. So let's cut it into 3 sections. So we've got 1 section, 2, 3, and it says each of these sections had a length of 7,200 centimeters. So 7,200 centimeters plus 7,200 centimeters plus 7,200 centimeters. That's the length of our whole rope in centimeters. Now the question says how many meters long was the original piece of rope. So we have to add up all of these lengths together and then make sure our answer is in meters. So you can add these up now in centimeters and change it to meters later, or you can change it to meters first. You'll still get the same answer. I might just change this to meters. So 7,200 centimeters is equal to how many meters? So you can use your length conversion chart or try it mentally. I know there's 100 centimeters in 1 meter, so I've got to divide by 100. I'm starting with smaller, so my number should get smaller. So divide by 100, 1, 2, so I get 72 meters. So I'm going to write the units down here. So I've got 72 meters plus 72 meters plus 72 meters. So I'm not working with centimeters now. I've changed it to meters. It's still the same length. So now, to work out the original piece of rope, the length, add them all up. Add up those 3 sections. So what is 72 plus 72 plus 72? Or we can go, what is 72 times 3? 3 times 2 is 6. 3 times 7 is 21. So we can say, therefore, it's always good to write a sentence as your final answer when doing worded problems. So the original piece of rope was 216 meters. They wanted it in meters. Okay? Okay. Question 14. Sally cut out a square piece from her sheet of paper. Okay, so there's the sheet of paper, and you can see there's been a square piece cut out of it. What area did she start with? What area did she cut out? And what area does she have left? So we can see this is a sort of like a composite shape. So have a go first. Okay, so for A, it says what area did she start with? So we know she had a rectangular piece of paper. So I'm going to just show that whole rectangle using the dotted line. Okay, so before she cut out that square, we had a whole rectangle. So we're going to work out the area of the whole rectangle. Well, the whole length is 6 centimeters, and then the whole width we can see is 4 centimeters. So area of the whole rectangle would be equal to length times width. Area would be equal to 6 times 4. Area will be equal to 24 centimeters squared. So that's the area she started off with. The whole rectangle would be 24 centimeters squared. Then she's cut out a piece, cut out that square. So now B, what area did she cut out? Okay, so we're doing B now. We know the shape was a square. So if I just draw that square, I want to find the area of that square, the part she cut out. So that's what I want to find now. Okay, so to find out the area of a square, I need to know its side lengths, at least one, because all the other side lengths are equal, and we know that of a property of a square. So if I can work out one side length, I can work out the area. So maybe I might go, okay, what's the area of this length here? To work that out, if I know the whole line here, the whole length is 4, okay, and I just want this part here, just like we did in the previous example, I want that part there. So take away that part, I can see it's 2. So if I go 4, take away 2, would leave me with 2. So the length would be 2, which means this length would be 2. And let's check and see. If I've got 6 here, take away that 4, yes, it leaves me with 2. And that length must be 2, and that length. So there are my dimensions of my square. So the area she cut out, area of a square is equal to length times length, the same length. So it's equal to 2 times 2. There's my square. If it helps, you can draw it separately to see it a bit better. Okay, a length of 2 all the way around. Area will be equal to 4 centimeters squared. So that's the area she cut out. Now C says, what area does she have left? So we have worked out A, the area she started with, B, the area she cut out. So I can use these to work out C. All I have to do is go, okay, if she started with the whole rectangle and then cut out this piece, which is a square, and I've got the area of both, all I got to do is go the whole rectangle, take away that piece she cut out, the square, will give me what we've got left, that L shape. So to use numbers, we have 24 centimeters squared, or can just write 24 for now. Take away 4 will leave me with 20 centimeters squared. So the area she has left is 20 centimeters squared. Okay, our last question for this session, question 15. So it says using a calculator, so we can use a calculator for this. Calculate the volume of the cereal box. Okay, and then for B, once you've got the volume, work out B. So have a go first. Okay, so to work out A, the volume of the cereal box, first we can see what shape it is. It's a rectangular prism. And we know the formula for a rectangular prism will be length times width times height. Okay? So now I can see I've got 27 and I've got 18 down here and 5.5 there. So I can see if I find the area of the bottom base, so 18 times 5.5 times it by 27 the height, it'll give me the volume. So volume will be equal to 18 times 5.5 times my height, which is 27. So you can use a calculator for this. So you should have gotten 2,673. Our units are centimeters cubed. So that one's for A. And now we can do B. If each cubic centimeter can hold 0.5 grams, so each cubic centimeter, so we have found how many cubic centimeters there are by finding the volume, can hold 0.5 grams of cereal. How many grams of cereal can this box hold? So all I've got to do is go, okay, 2,673, that's how many cubes I have, centimeter cubes, and each one can hold 0.5. I just multiply it by 0.5. So what I'm really doing is finding half of this number, but you can just put it into your calculator. So you should have gotten 1,336.5 grams. Okay, so this box, if you want to write a final statement, you can as well. So this box can hold 1,336.5 grams. An extra thing, if you want to also work out how much is that in kilos, because usually once we reach 1,000 grams, we start saying our units in kilos. But the question just said to write it in grams, so if you've got that, that's great.